Hi there, so welcome back to the channel and welcome to Excel Island, where the goal and objective is to learn and master Python over the next 100 days. We are on day 59, and we're actually 63% throughout the whole 100 days learning journey, which is we're actually following the career track or data analyst with Python on the DataCamp platform. So we're on the eighth course, which is Introduction to Data Visualization with Seaborn. We're actually on the last chapter in this course. So the whole career track actually contained 15 courses, including projects and some a couple of projects, one or two or four projects in this whole career track. And we're actually so each courses has four chapters. So we're on the fourth chapter in the eighth course, which is Introduction to Data Visualization with Seaborn. We're just going to continue from where we stopped on the 58th. So in which we had a couple of little of technical issue. So I have to end the live stream. I'll just continue from that chapter. I'll just go ahead and start sharing my screen. So all the exercise files, Jupyter Notebook files, and data set that we'll be using over the last couple of 59 days is already linked under the YouTube description. So do make sure to click those links and download this file. I'll just start sharing my screen really quick and continue from this introduction to data visualization with Seaborn. So I have my files open. Let me just launch these files. So these are the four CSV file we'll be using to practice to understand data visualization with Seaborn in Python. Let me just zoom in a little bit there. Voila. So that's it there. So I just open this last chapter here. So on chapter 4. So changing plot style of Seaborn charts. So that will just launch. So we just continue from here. So we're actually trying to solve this challenge on day 58. So you can catch up on that. So we've learned all about all these libraries, how to work with them. That's the basic though. Yes, so this was the last plots we plotted using this context, this line of code here. By using a cast plot syntax to plot a bar plot using siblings and loneliness variable from this data set here that we connected to here, which is this line of this column here, loneliness, and the siblings column, which is this one right here. That's the basic thing we did on the last live stream. I'll just continue from here. So it says, let's continue real quick. So in this exercise, we'll continue to look at the data sets containing responses from a survey of young people. So the data we're actually working with is the response from this survey of young people. So that is actually what we got connected to using this line of code here. I'm just going to continue right there. So does the percentage of people reporting that they feel lonely vary depending on how many siblings they have? Let's find out using a bar plot while also exploring Seaborn's four different plot skills. Context. So we've already imported Seaborn as SNS and matplotlib as .pyplot as PLT. So let's set the context to paper. So let's set context. So that will be SNS dot set context. I think we're going to mention that to paper. Set the scale context to paper, which is the smallest of the scale options. And so this is what we did here. Number of siblings feel lonely. So I'll just copy this line of code here. Let's run the code and see first. Oh, voila. So if you're looking to understand what is happening here, just go and watch day 58 live stream. We actually went through a couple of lessons explaining all of this to us, which is this lesson here. Journey plot style and color, which is this one here. If you submit, let's see if you're right. Great, we're actually right. So change the context to notebook to increase the scale. So I'm going to change the context to notebook. I'm just going to change this line of code to notebook. That'll just be notebook. So if you want to know what paper, notebook, talk, and poster is, all this, just go ahead and watch the lesson on that. I'll just copy, let's run the code and see what we have here. You can see. So just changing the scale, increasing and decreasing the scale of our plots. I'm just going to paste this here. But before that, I'll go back real quick and run on this line of code. See, let's run this line of code. Oh, okay. My data is called YPL. I'd say YPL. YPL. Oh, what's the problem? Oh, okay. My variables are different. These are siblings and loneliness. In this instance, here, okay, let's do that one more time. And voila, we have a beta plus now. You can see siblings 0.0, 0.0, 1.0, 2.0. We're having the same thing there. You can see the bar plots are kind of different. So you may not get the differences that much yet, but the scale are kind of increasing. Let's submit and see. Change the context to talk to increase the scale. I'm going to change the context here to talk. Let's run the code. You can see. So let's do the same thing right here. Okay. This is going to be talk. And this is going to be YPL. We call that YPL. What is going to be siblings and loneliness? As usual, siblings and loneliness. And let's run the code and see. Voila. Can see so it is changing the bar plots, changing the scale of the plot element and labels. You can see this is quite different. This is quite different. So that's what actually changing. The design of the elements in the chart. Now this is thinner, which is paper, which is paper. This is thinner. This is slightly curved here, and this is round at the top here. So that's just the difference between those line of code. The last one is poster. Let's see what poster looks like. Poster. Quite different also. Let's copy this line of code and give it a shot in my Jupyter notebook item. It's going to be YPL. Let's copy these variables that we are using here. Let's see what we have. Voila. You can see that the spacing, the spacing of the chart is quite different. This is bigger and closer. This is thinner. This is thinner also and wider. You can see all the difference between those contexts. Interesting. So let's continue. and submit. Good job. So each contest name gives Seaborn suggestion on when to use a given plot scale in paper, in an iPython book, in a talk presentation, in a poster session. Okay, that's what this contest actually did. It's showing us how to use a given plot scale. So using a custom palette. So it says so far we've looked at several things in the data set of survey response from young people, including their internet usage, how often they listen to their parents, and how many of them report feeling lonely. However, one thing we haven't done is basic summary of the type of people answering this survey, including their age and gender. Providing this basic summary is always a good practice when dealing with an unfamiliar dataset. The code provided will create a box plot showing the distribution of ages for male versus female respondents. Let's adjust the code to customize the appearance, this time using a custom color palette. So this is going to show the distribution of ages for male versus female respondents by age. So set the style to dark grid. So I want to set the style. So set style. The line of code to do that is going to be SNA dot set style. SNA dot set, of course, style. So when you set the style to dark grid, so it's going to be dark grid as the name suggests. Set a custom color palette. Set a custom color palette with the X color code. We want to set a custom color palette. So that will be SNS dot set underscore palette. So how do we set the line of code there for the palette? Hmm. I'm looking at how to include our custom palette in the line of code. That like two different ways to do it. I could say set color palettes. Hmm. Okay, it could just be this palette here. I'll just copy it, then comma. I'll copy this palette here. Let's see if it works. I think there's going to be an error in this palette line of code here. Let's get up on the error and see. Select those palettes. Maybe also create a palette, custom palette before to include that. Okay, I have to wrap it in square brackets. That was my mistake. Let's run it again. And voila. Interesting. We nailed that. So let's give it a shot in Jupyter Notebook here. But my gender, is this gender here? Do I have a variable called gender in my data sets? I have age, correct, and I have gender. I think I have gender. Yeah, it's spelled gender and age. So let's see. We are putting a box plot for it, but my data is called YPR right here. YPR. Great. So we can see the distribution of male versus female. So the age difference, so on average, we have average mean of 20 for the females. And I think this is also 20, average age of 20 for the males. Interesting. I have two colors there. Why it is showing just one single color here? How did I do that? It's not showing the two colors in those instances. Let's submit and see. Good work. It looks like the median age is the same for male and female. Exactly. So the median age, you can see is 20. The median age is 20 also. Okay, so let's see what we can learn today again. So we will understood how to create changing the scale and using a custom palette. So let's see how we can add titles and labels to our plots. We can add titles and label right here. Titles and labels. But we want to change the labels for these plots.
Welcome! In the next two lessons, we'll go over one of the most important parts of any data visualization: plot titles and axis labels. We create data visualizations to communicate information, and we can't do that effectively without a clear title and informative axis labels. To see this, let's compare two versions of the same visualization. On the left, we see box plots showing the distribution of birth rates for countries in each of 11 regions. On the right, we see the same visualization with three key modifications to make it easier to understand. A title is added, which immediately orients the audience to what they're looking at. The axis labels are more informative, making it clear that birth rate is measured per 1,000 people and birth rates are measured per country in each region. Finally, the x-axis tick labels are rotated to make it clear what each region is called. Let's learn how to make these changes. Before we go into the details of adding a title, we need to understand an underlying mechanism in Seaborn. Seaborn's plot functions create two different types of objects: facet grids and axes subplots. To figure out which type of object you're working with, first assign the plot output to a variable. In the documentation, the variable is often named G, so we'll do that here as well. Write type G to return the object type. This scatterplot is an axes subplot. A facet grid consists of one or more axes subplots, which is how it supports subplots. Recall that rel plot and cat plot both support making subplots. This means that they are creating facet grid objects. In contrast, single-type plot functions like scatterplot and countplot return a single axes subplot object. Let's return to our messy plot from the beginning. Recall that catplot enables subplots, so it returns a facet grid object. To add a title to a facet grid object, first assign the plot to the variable G. After you assign the plot to G, you can set the title using g.fig.subtitle. This tells Seaborn you want to set a title for the figure as a whole. Note that by default, the figure title may be a little low. To adjust the height of the title, you can use the Y parameter. The default value is 1, so setting it to 1.03 will make it a little higher than the default. We'll learn how to add a title to an axes subplot object in the next lesson. For now, let's pause and practice what you've just learned.
So to add a title subtitle, you need to understand whether the plot is a facet grid or a axis subplot. And we know that plot type, the real plot and the cat plot allow you to create subplots, while the scatter plot and count plot does not allow you to create subplots. Interesting. Now let's see what we can do and create this type of plots. So facet grids versus axis subplot. So in the recent lesson, we learned that Seaborn plot functions create two different types of objects, facet grid object and axis subplot objects. The method for adding a title to your plot would differ depending on the type of object it is. In the code provided, we've used real plots. And we know that real plots can create subplots. With the miles per gallon dataset to create a scatter plot, showing the relationship between a car's weight and its horsepower. Do we have access to that data set? Let's see. Miles per mpg, we have it here. But we just connect to it again for this instance. So this scatter plot is assigned to the variable name g. Let's identify which type of object it is. We've already imported the necessary libraries. Okay. So we need to identify the type of object it is.